The electrical connectors on a professional motorsport harness suffer a lot of abuse and often see many more mating cycles than they would for a comparable street car. When we're in the situation where we can choose the connector to be used, like when we're specifying a sub-harness interface or a connector on a flying lead of a potted component, we'll use a circular metal-bodied connector made specifically for motorsport applications. These connectors have quite high pin densities, making them small overall, and are easy to reliably mate and unmate using a quarter-turn locking mechanism. There are two main manufacturers of this style of connector: Souriau with their 8STA range and Deustch with their Autosport range. Within these ranges, there are numerous subcategories of connectors, but for the most part, Autosport and Souriau connectors are intermatable, and it's very common to find both brands used in a single harness. Most often, the deciding factor on the brand comes down to whichever connector your supplier could get you in the shortest amount of time. We'll first look at how to specify one of these connectors for your application. Like with specifying any other connector, the most critical piece of information you'll need is the number of individual wire connections the connector needs to make. This could be only 2 in the case of a simple temperature sensor, or more than 100 in the case of a main firewall sub-harness connection point. You will also need to know the amount of current that will be passing through each pin connection. This will, of course, be closely linked to the wire size that the circuit is using. The Autosport or Souriau 8STA connectors are available in many different shell sizes, which specify the physical size of the connector body itself, the spacing of the mounting holes if it's a flanged receptacle, and the size of the sealing boot to be used. Within each shell size, there are various conductor arrangements available. Higher density arrangements with smaller conductor cavities are applicable for low current applications, and lower density arrangements with larger cavities for high current applications. There are 2 sides to every connector, the plug and the receptacle, which when combined form a mating pair. Both plug and receptacle connector bodies are available in versions that take male pins or versions that take female sockets. This can get a little bit confusing, but to have a pair of mating connectors, they need to share the same shell size, the same conductor cavity configuration, with one side taking male pins and the other side having female sockets. The receptacle connector bodies are broken down even further into different styles, usually being available in a flanged version with 2 mounting holes and a free hanging version. Most often, the flanged version is used, as it can be mounted easily, giving a good solid connection point for the plug, which contains the locking collar to make a connection to. For the most common connectors, it's usual to refer to the connector by the shell size and conductor configuration number. An 1835 plug, for example, refers to a plug with shell size 18 and conductor configuration 35, which in this case actually means it has 66 22 gauge conductor cavities. Having a look at a mating pair of connectors here, we'll decipher the part number and talk about what each part of that is going to mean. You can see this is a Souriau connector, and it's an 8STA0 1835SN. So breaking that down, the 8STA is simply the connector classification. This is part of their 8STA connector range. The 0 refers to it being a flanged receptacle. We've got 2 mounting locations here, and this is a receptacle onto which we mate a plug. The 18 is the shell size, and the 35 is the conductor configuration, which, as we mentioned earlier, is 66 22 gauge pins. The SN on the end here means that this is a receptacle set up to take sockets, and the N refers to it being a red band keying. These receptacles and plugs are available with different coloured bands, which actually change this internal keying arrangement, and you can only key together matching receptacles and plugs of the same coloured band. If we have a look at our plug here, we'll decipher the part number on that and just see how it differs. So this is an 8STA6 1835PN. So 8STA, once again, just the series of connector. The 6 refers to this being a free hanging plug. So that is the mating side for a receptacle. 1835 is once again the shell size and the conductor cavity configuration. PN means this plug takes pins, and N is our red band again. For mating a pair of connectors like this, if we line them up with one another and rotate them, eventually those internal keys will line up and they will click together. At this point, you rotate this outer collar and it will grab onto those bayonet pins, and then with a simple quarter turn, it'll click and lock into place. A larger connector like this can actually be quite stiff to lock into place, particularly when it's brand new. There's a good visual indication on the top here. You can see one of those bayonet pins through an inspection hole, and that's a really important detail as it allows you to tell at a glance that this connector is fully mated and those pins and sockets will be fully seated with one another. We'll have a look now at how we crimp a pin for one of these connectors and insert it into place. At the Club Sport Spec harness level, we've used general purpose crimping tools for the majority of our crimping applications, while still ensuring that we achieved a professional and reliable result. Motorsport connectors like these, however, are another instance where we absolutely need to be using the manufacturer specified tooling to ensure that we get the best possible result. Using the wrong tooling could lead to pin, socket, or even connector body damage, and with them being quite expensive, that should absolutely be avoided. The correct tool in this application is going to be our Daniels Manufacturing, or just DMC AFM8. Having a look at this tool, the first thing to know about it is that it is a circular indenter tool for closed barrel contacts, which are the type of contacts we're going to be using with these circular Race Spec style of connectors. You can see on the back here that if we squeeze the handles, it's also a ratcheting or a controlled cycle tool, meaning once the crimp operation has begun, it won't actually be able to be released until they've been squeezed all the way and the correct amount of crimp pressure has been applied at the crimp end of the tool here. You can see with the handles closed here, we've got our indenters coming out into the crimp location. There's 4 of those, each one having 2 points, and that makes for an 8 indent crimp, which is the correct specification to be used with these pins. Now, this particular tool is a very high precision calibrated device, and it is also quite expensive. To avoid the need to purchase a different tool frame for every pin or socket crimping application that we're going to be using, instead you buy selectable positioners which clip into the head of the tool here. Now, what these positioners do is they locate the pin in the correct place to ensure that when the crimp operation is performed, those indentations happen at the right place on that pin or socket. The positioner I've got in here at the moment is actually for size 20 pins or sockets. So I'm just going to swap that out quickly with the correct positioner here for a size 22 socket. We're going to go through an example very shortly of pinning one of those into our connector body here. So you can see it's very, very easy to change those out on the fly, and that's really, really handy, meaning that we can just have our one expensive calibrated tool frame, and we know with the correct positioner in place, we're going to have the correct crimp location every time. First part of that pinning process is going to be stripping a section of insulation from our wire here. The wire I've got is Tefsel or M22759/32 wire in 22 gauge. It is going to be the right size for the connector body that we're going to be using, which is our 20-35 connector. We talked about stripping this wire in the wire preparation section and the tools you need to use for that. I've got my Ergo Elites here, and I've set the wire stop to the correct strip length for this. I'll get this piece of insulation stripped, and then we'll have a talk about how we confirm that that strip length is correct. The Ergo Elites have done a really nice job of stripping that. The wire hasn't frayed out at all, and that's going to make getting our pin into place actually very easy. So the pins for these connectors are a closed barrel pin as opposed to a lot of the open barrel pins that we've used previously, and that's why we need to use an indentation crimping tool like the DMC AFM8 there. Sliding this pin into place, we can see that we've got the correct strip length there. I've got full copper engagement in that closed barrel, and I've got 1 wire diameter or less of exposed copper conductor strands at the point where the insulation ends here. That's going to give us a bit of strain relief if this terminal ever needs to move. The insulation isn't going to push on the base of the terminal, which can lead to failures. With that in place, we're going to move back to our DMC tool and make sure we've got it in the correct setting. These tools have a dial on the front here, and adjusting the setting on that dial will adjust how far the crimp indenters come in when we complete a crimp operation, and that will need to be changed depending on the pin or socket and in fact wire size that you're working with. Determining that setting is quite easy, however, as it will be listed on the positioner that you've got in the tool, which will be correct for the pin that you're working with. In this application, we're using size 22 wire, and with these terminals I'm going to be wanting to have that on setting number 4, which is actually a very common setting, and that is the setting that it's on there at the moment. If you need to change this setting, you simply remove the lock pin, make sure the tool is completely released. You don't want to adjust the setting with the tool halfway through a crimp cycle. So with the tool released, you simply raise this knob and you can turn it to the new setting. So we'll just put that back on setting 4 there, as it is going to be correct for our application here. So I can get my wire and pin assembly into the tool here, making sure that it is bottomed out on the stop in the positioner. Determining the positioner to use for a particular pin or socket and wire size combination is going to be a case of referring to the documentation that we've linked below. The positioners to use are listed in there. With that bottomed out in our positioner there, we can just do a quick visual inspection to see if that crimp indentation is going to be in around about the right spot, which it is, and I've got it on setting 4, which is correct for this pin and wire size combination, so I can squeeze those handles and undertake our crimp. Now I need to do a little bit of a visual inspection on that crimp join. What we're looking for are 8 nice even indentations in 4 places radially around that closed barrel pin. Each indentation will be one above another, giving you 8 in total. What you're also going to be wanting to look for is the inspection hole. You're going to need to make sure that that isn't ovaled at all and that you can see the conductor strands of the wire through that. All those points are going to ensure that you've got a nice solid crimp connection there that is going to be completely reliable. With our pin crimped into place, we can have a look at how we're going to actually insert that into our connector body here. So the connector body we're using for this example is the AS120-35SN. So Autosport 1 means it is a free-hanging receptacle. The 20-35 is the shell size and the pin configuration, S for sockets, and N for a red band. To insert our pins into connector bodies like this, we are going to use a specific tool for the job. This is an insertion/extraction tool. So we use it when we are inserting a pin into the connector body, but we also use it if we're wanting to extract that pin from the connector body as well. You'll be supplied a new one of these with every connector body that you purchase, and if you're careful with them, they do actually last quite well, so you end up with a little bit of an excess of them. It's never a problem though, as you always want to make sure you've got one on hand when you need it. The first thing about these tools is that they are plastic, and they're plastic for a very specific reason. They are a little bit fragile, and they're made that way so that if anything goes wrong, the chances are you're going to be damaging your insertion/extraction tool and not your expensive connector body. There are aftermarket pinning and depinning or insertion and extraction tools available for these applications, but I would recommend staying away from them, as you don't want to be in a situation where usage of one of those tools actually damages your expensive connector body. To use one of these tools, we need to identify which is the insertion end and which is the extraction end. On this style, it is actually embossed on the plastic here, but if it's ever in doubt, the insertion end will have a chamfered end to it, whereas the extraction end will be a full circular profile all the way to the end. To use this tool, I'll get my pin and wire inserted into it here. The way this works is that the wire is going to slide down into the channel in the tool here, and we're then going to pull it back until the end of the tool butts up against the locking flange of that pin. With that in place, while we're holding everything, we can go to the back of our connector body and insert that pin into place through the rubber seal. Now, if you find things get a little bit tight when you're doing this, you can actually use some isopropyl alcohol as a really good lubricant. Helps that pin slide in there really easily. Because this is a completely new connector body and everything is in place, it is actually going in quite easily. IPA is a good lubricant to use though, because it will evaporate away, leaving no residues behind. We can insert that pin the entire way until we hear a nice click, like so, and then we can simply pull the extraction tool back out, and because that pin is now locked in there, the extraction tool will come out and everything will be held in place. Our example out here on the bench, chances are very good we could have actually installed that pin and wire by hand, but when you're working with these connector bodies and you get a few wires into place, the insertion and extraction tools are actually really invaluable, as they help you get wires down into those tighter locations that might be obscured by other work that you've already done on the back of the connector there. There's a key detail to using these tools that I really want to emphasize, and that is when you have them inserted down in the connector body there, you never ever rotate them for any reason. Down inside these connector bodies are plastic molded tines that actually lock on to the flange on the pin and keep everything in place. Those tines are quite small and fragile, and if you have your insertion or extraction tool in place and you rotate it, chances are you're going to end up snapping one or more of them off, and that is basically going to render your connector useless, as that connector cavity location now will no longer hold on to a pin. We'll have a look at the opposite of the pinning process now, which is going to be our depinning or extraction process. It's very similar. However, we're going to use the other end of our tool here with that full cylindrical profile on the end. The way this works is that that cylindrical profile is actually going to unlock all of those tines that we've just talked about and allow us to withdraw the tool and the wire and pin assembly as one. So I'm going to get my wire down the channel in that tool there, and we're going to insert this into place. Once again, IPA or isopropyl alcohol can be a really good lubricant in this situation. But I can get this tool down there. You want to push it down until you feel it bottom out on the flange on that pin there, at which point it will have unlocked those tines. Can be a little bit of a process you might need to take a couple of goes at, but once again, never ever be tempted to rotate this extraction tool when it's inserted into that connector body, as it is an almost guaranteed way to damage those tines. With that in place there, I can feel it butted up against that pin, and I can simply pull everything out as one and depin that connector location really quite nice and easily. Earlier on, when we crimped this terminal onto this wire, I went through what type of wire we were using, and that was a really key point, as these connectors can only be used with the correct type of wire. The reason for that being that our TEFZAL or M22759/32 wire has a very tight tolerance on its finished outside diameter, and we need that to be within a pretty narrow range to ensure that that wire will fit nicely in our extraction tool here, and that extraction tool can slide over our crimped join and butt up to the flange on that pin there. If we'd used another type of wire that had a larger overall outside diameter, chances are it would expand this tool out too much and it wouldn't actually fit into the back of our connector body anymore. In that situation, you can quite often be stuck with a location in your connector body that you just cannot depin. If you're trying to salvage an old connector body, this can be quite frustrating. There is a trick that you can try. It could actually end up damaging things, but if you're in the situation where you're wanting to salvage an old connector body, you can't actually make the situation any worse because you can't use that connector body at the moment anyway. So the trick is to clip that missized wire off quite close to the back of the connector, and with a little bit of heat, try and remove the insulation from that wire, just leaving the copper conductor strands coming out of the back of the connector. That should give you enough clearance to insert your extraction tool, hopefully unlock those tines and get that pin out of place. It's absolutely not a guaranteed solution, but you can't make the situation any worse by trying it. When it comes to the order in which you pin these connectors, it is best practice to, if possible, pin them from the inside out. This is quite tricky to show on the bench here with our single example, and we will go into it in more detail in the worked example section of the course. If you're using one of these connectors to specify a sub-harness interface and you're actually designing the pin layout, it can be very, very useful to match that pin layout to your concentric twist layup as much as possible, as it's going to make everything much easier when you're terminating that concentrically twisted harness section to your connector. Going to go through an example of terminating our potted engine position sensors here to a circular Motorsport connector. The connector for the job is going to be an ASL 0605SN. We'll just break down that part number quickly. The ASL means it is an Autosport Lite, so they're a miniature bodied connector really commonly used in sensor applications like this. The 0605 is the shell size and the pin configuration, so size 6 shell size and 05 in this instance simply means we've got 5 22 gauge conductor cavities there, and it's an SN meaning it takes sockets and it's a red band keying connector. First thing I need to do is to strip a section of the insulation from the end of our pigtail here. This is all 22 gauge wiring, which is going to be the correct size to be used with the pins for our Autosport Lite connector here. So quickly off camera, I've gone ahead and I've reset the stop on our Ergo Elites here, just going to make getting a consistent strip length on the end of all these wires really easy. So I'll just go ahead and get those stripped now. We've got our sections of insulation stripped there with our Ergo Elites, which have given us a nice consistent strip length with that stopper on there. Sliding our pin into place, we can see that we've got our required gap where the insulation ends here of 1 conductor diameter. So now we're going to have to undertake this actual crimp join. I'm going to have to swap out the positioner on my AFM8s here for the correct positioner for this application, which is going to be a K1414. Now, swapping out that positioner, once again, you want to make sure the tool is in its relaxed state, and it is as simple as pushing down and turning that and pulling it out of the way. We can get our other positioner here and get that into place. Having a look at the data on the back of that, we can see that we're using 22 gauge wire. We're using a size 23 socket, which is correct for this application. So we're going to want to have it on pressure selection 4, which I did mention is a very common selection, particularly with 22 gauge wire. So we're already on the correct setting there, so we don't need to change that. I can now go ahead and get this installed into the back of the tool here. Making sure we're butting all the way up against the stop in that positioner, and I can undertake that crimp operation. Like so. Quick visual inspection to make sure everything's gone fine, looking for those 8 nice and evenly spaced indentations there, and that we can see the copper conductor strands through that inspection hole, and that inspection hole hasn't been deformed. The process is going to be exactly the same for our other 2 conductors here, so I'll go ahead and get that done now. Got our connector pins crimped into place there, and everything's looking really, really good. Now, I have kept our wire lengths past the end of our sheathing here quite short, as when we pin into this connector body, I want this connector body quite close to the end of our sheathing here, as we are going to be booting this connection point, which we'll be covering in another module, and I want that boot to be sitting in a particular location. Now, when it comes to inserting these sockets into this connector body, we are going to be using our insertion tool, but we're also going to be putting some service loops into them. Now, service loops are simply going to be where the wire is looped around itself before heading to our connector body. We undertake service loops for a couple of different reasons. The first is that once this connector body is in place and it is booted, they're going to give us a good amount of strain relief. Any force that is put on this harness is going to be transferred through the harness sheathing, through this boot, to the connector body, and it's not going to be able to be passed through the wires, as that service loop is going to give us a nice dead zone in there. The other reason is that if we ever need to perform any repairs or repin this connector at all, that service loop is going to give us a little bit of extra wire, which we're going to be able to tease out and get our extraction tool into place. To put that service loop in place, I like to use the end of my seal pick here and simply twist that wire around the end there, which is going to give us a good loop. We can then use our insertion/extraction tool, get that in place, butt it up to the flange on that pin there, and then insert it into the connector. Now, for our engine position sensors here, our blue stripe wire is the positive, our white wire is the negative, and the green is actually connected to the shield of this cable section here. The pin out for the sensor is going to be pin 1 positive, pin 2 negative, and I'm going to put the shield into pin 5. So with everything set up here, I can pin this into location. Get that lined up with number 5 there. It's going in nice and easily, so I don't think I'm going to need any IPA for lubrication. And simply slide that into place. Hear the little click, withdraw our tool, and that's now pinned into place. The operation is exactly the same for our other 2 wires here, so I'm going to go ahead and get those pinned into place now. I've got all of those wires pinned into position now with our service loops in place. In this particular example, we are working slightly closer to the back of the connector, as the boot we're going to be putting on this, I want to be shrinking down into a very specific position. When you're working with a larger connector, what you find when pinning, we did mention it earlier on, is that you want to start from the inside and work outwards. You also want to be staggering the location of those service loops. Typically, the service loops are going to be further away from the connector for the inner conductor cavities and get closer to the connector as you move outwards in the layers. We will be showing this technique in a wee bit more detail in the worked example sections of the course. This should give you the knowledge needed to specify a connector for your particular application, all the way from a minuscule Deutsch 3-pin ASX up to a monster Souriau 24-35 with 128 22-gauge conductor cavities. Paramount with these connectors is taking your time during assembly and pinning, using the correct tools and as much planning as possible. While all your hard work is going to be hidden away behind a molded shrinkable boot, knowing that everything in there is tidily installed and strain relieved will ensure your harness is reliable for many, many years.
That was just one of the many modules taken from our course. You'll start with the basics and build on the knowledge in this course to be able to do it yourself. If you're interested in advancing your skills, this is the course for you. For more information and to purchase this course, click the link to enroll now.